Hello there. In this video, we are going to do a practice of one sample hypothesis testing. And let's just go ahead and jump in using our flowchart. So in this one, it says, StreamPro Plus, a subscription-based streaming service, recently implemented a personalized recommendation algorithm designed to improve customer retention. Historically, 44% of first-month subscribers renew their membership. The marketing team randomly sampled 370 new subscribers and recorded whether they renewed after their first month. In this sample, 179 subscribers renewed. The company wants to test if the 5% level of significance to determine if the retention rate has significantly increased since they utilized their new recommendation algorithm. Okay, so let's jump in and take a look at what we've got. So for our step one, we notice that, let's just go ahead and do, what is our question? And the question that is being asked is, did you renew after the first month? And the response, is going to be yes or no. All right, so if it's yes or no, we know that the data type is categorical. And specifically, this is nominal. It has no order to it. Okay, so we've got a data type is nominal, which means that we want to know a true proportion. And then the symbol of interest is going to be pi. And that all comes from our step one. All right, step two is like determine our population. So our population is equal to subscribers, or like first time subscribers, or first, let's say, month subscribers of StreamPro Plus, and the parameter is going to be true proportion to renew their membership. Okay, let's go ahead and do step three then. So in three, we need to do our null hypothesis, H sub 0, and we need to do our alternative hypothesis. Sorry about that, H sub 1. And since we know that from step one that what we are interested in is pi, we can go ahead and put those in. Now let's go ahead and get our symbols. So let's kind of drag it on over. So we know that proportions, we're dealing with pi, and we want to know if, in here, we want to know at the 5% level of significance, determine if the retention rate has significantly increased. So we want to know if this true proportion has increased from our historical rate, which looks like up here is 44%, 0.44. And so we'll do 0.44. And so that means that that is going to be like less than or equals to for our alternative hypothesis, because this is going to be opposite of what our alternative hypothesis is. So we also know that, pi sub 0, we set that up over here, is equal to 0.44. Fabulous. So we got that. And tails, this is a one-tailed test. Two tails is when we have not equals, and that's stated right down here in our, at the bottom portion of our step three. All right, step four says we need to establish our alpha. So we can just, we can say that alpha equals, and up here, what's our alpha? 5% significance level. So we've got 0.05 for our alpha. Let's go ahead and do step 5. We have determined our testing method. So we ask if we're dealing with means or proportions. We're dealing with proportions. So we are going to do a one sample z-test for proportions. Okay, moving on to step 6. We need to do a central limit theorem check. So central limit theorem check is step 6 right here. Proportions, remember the original distribution is never normal, so we can't get out that way. So what we need to do is we need to do our sample size times our hypothesized proportion. So what was our sample size going to be? It says it's going to be 370. We're looking at these new subscribers. And how many do we expect to be like expect yes and expect no to resubscribing. So the expect yes is going to be equal to our 370 times our hypothesized true proportion. And the expect no is going to be 1 minus our hypothesized true proportion times our sample size. So because both are at least 15, so we are good to go for the central limit theorem. Fantastic. All right, step 7, we need to gather the data, which we already have. And we are on to step 8. So step 8, let me scroll over real quick. Step 8 is our test statistics, our p-value, and the z and the t critical. Okay, so we need to go over to our proportions. And let's go and gather everything that we need. So we're going to put in z. Or actually, we'll just start off with k equals, n equals. We'll do p equals. We'll do pi not equals. And we'll do the standard error equals. Okay, so k equals. How many actually resubscribed? We had 179 out of a total of 370. So our sample proportion, when we have we need a sample proportion, it's either going to be given to us or we do k divided by n. That gives us our sample proportion. Our pi's, well, we already decided that. Our pi naught was that 0.44. And the standard error, notice it's equal to the square root of pi naught times 1 minus pi naught divided by n. So we'll do equals square root of our pi naught times 1 minus pi naught, divided by our sample size. And that gives us our standard error. Now that we have our standard error, I can calculate out my z-score. That is just going to be equal to parentheses, look up here, it's right here, sample proportion minus hypothesized population proportion divided by the standard error. That gives me my z-score. Because I am doing a greater than, we can match up our p-value. Let's go over all the way to the left. P-value for greater than. It's going to be our bottom option for our p-value. So we're going to do p-value equals, and let's do it, 1 minus norm dot s dot dist of the z-score that we have and comma true. And that gives us a p-value. And now we want to go ahead and calculate out the z-crit. And we're going to do a one-tail. And that's going to be the norm dot s dot inverse. It's right here, z-critical one-tail. Why did I choose one-tail? Because in step 3, I know that we're doing a one-tail because we're doing a greater than test. Okay, so we've got our 1.s dot inverse of 1 minus our alpha value, which we said was 0.05. And we can go ahead and hit enter there. And so now we have our z critical. Perfect, we got through step 8. Let's go ahead and do step 9. Bring it over. Down here, we can go say that step 9 is we are either going to be rejecting or failing to reject. And we compare our p-value to our alpha. Alpha is 0.05, p-value is 0.04. So we are going to reject because our p-value is less than our alpha term. So in step 10, we can now write out a conclusion. Let's go ahead and write it out. So we can say that we have, let's go down and get to your, like how we actually write those out. Here we go. We have collected sufficient evidence. And then we need to put in our z-score. We need to put it in. Our z-score is 1 point, this looks like 697. There you go. We can put in a p-value. The p-value equals 0.045. And then our alpha level equals 0.05. Okay, to reject the claim, now we need to reject our baseline assumption. So we're rejecting the claim that the true proportion is less than or equal to, claim that the true proportion, oh my goodness, sorry, proportion of first-time subscribers who renew their membership at Stream Pro Plus is less than or equal to 44%, and instead we conclude that the true proportion who renew is greater than 44%. All right, so we can say that it's greater than. Now that we say that it's greater than, we should probably do a one-tailed greater than, and let's get out our confidence interval. So we need to do a confidence interval. We need to do a lower-tailed confidence interval. So let's go back up here for our proportions. So we're in our proportions, and let's do our confidence interval. Now there is one really important thing that we need to know. So we're dealing with proportions down here. We know that our lower tail is equal to here. So we've got a lower tail value, and it goes all the way up to 1. Let me show you what we need to remember about doing our confidence intervals. So confidence intervals for the lower tail. I need a sample proportion, P, and I've got a sample proportion. I'm just going to grab it from over here. I already have my sample proportion. It looks like that I also, for this lower tail, I need a Z one tail. Great. And do I have that? Yep, I've got my Z critical one tail. I'm going to grab that right there. Now, I need a standard error, but I'm going to label this as standard error CI for confidence intervals, because when you're dealing with proportions, the standard error is different. There's a different way to calculate it when we're dealing with confidence intervals. If we remember when we did our standard error over here, notice how we used the hypothesized true proportion, because we think that that is the true proportion, and that we use it to calculate out our standard error. But when we do confidence intervals are saying like, hey, I'm not quite sure what the true proportion is. So the best guess that I get to use is my population standard, or it's my sample standard deviation. So look in here, when we calculate our standard error for confidence intervals, it's square root of the sample proportion times 1 minus the sample proportion divided by n. So we need to actually calculate this for the confidence interval. So here we go. The square root of the sample proportion times 1 minus the sample proportion divided by the sample size. And we hit enter. There's my new standard error. And notice it's close. It's really close, but it is slightly different. So we're going to have a lower value and we're going to have an upper. And we are doing a lower tail confidence interval because we're doing, notice how our alternative hypothesis has a greater than symbol. Notice down here, the greater than symbol corresponds to a lower tailed confidence interval. Okay, so we're doing this lower tail. Lower tail is going to be equal to the sample proportion minus the one-tailed critical times the standard error for the confidence interval. And the upper is going to be the number 1. And so now we have our confidence interval that we are 95% confident that the true proportion of individuals who resubscribe is greater than 44.1%. So just a little bit bigger, but we were able to show with some data that we think that it is greater than 44%. Okay, so let's go through and do all of these. So we did all of these steps, and let's go see what are the null and alternative hypotheses. So we said that the alternative hypothesis should be greater than, but it's not this 0.85. We need to be greater than that 0.44. Fantastic. The best point estimate. So the best point estimate for the proportion of renewing customers is our sample proportion. And our sample proportion is at 48%, or that 48.38. So when we computed the test statistic, that's our z-score, and we got 1.689 or 698. That's what we got down here. Let's keep on moving. It looks like there's a tiny bit of a rounding error, and it's probably from how one of these values was rounded in the calculation, but it is by far the only one that is close enough. So just a little bit of rounding. All right, what is the computed p-value for this test? The computed p-value is 0.448 or 0.0448. That's our p-value that we got. And what is the critical z-score? So the critical z-score, we got 1.645. Excellent z-score. Based on this hypothesis test, what is the correct decision? Correct decision is to reject, which is what we said. So we conclude that there is sufficient evidence to suggest that the new recommendation system has increased customer retention program, right? That's what we were looking at. It's like they added in this recommendation program, they've retested, and it says that there's some evidence to suggest that we've increased our customer retention. What's our 95% confidence interval for this? We said 44, 105. This says 4414. This is just a slight rounding inside of the inside of MyOpenMath, and then it goes to, this actually needs to be fixed. It should go to 1, not to infinity. I will fix that in the problem here in just a second. Does the central limit theorem apply? We can say yes, because n times p and n times 1 minus p are both at least 15. We got through that. What would a type 2 error? Okay, let's go look at a type 2 error. If we go in here and we look at a type 2 error would be where we fail to reject, but the null hypothesis is actually incorrect. So we would say that, let's see, we failed to reject when the retention, let's see if we've got it even right in here. Yeah, so we failed to reject the null hypothesis. When the retention has actually increased. That's correct. So we failed to reject the null hypothesis, which means we say that the retention really hasn't done anything, but retention has actually increased. Perfect. So if SteamScrew increased the sample size on future study, how would this impact the hypothesis test? And again, a larger sample size decreases the standard error, making these tests more precise. Anyhow, this is how we get through one where we are dealing with proportions instead of means. Good luck practicing for your exam.